Okay, here we are at the final electronics design. So if you came from the initial one, you'll immediately see how much more simple this is. So there's no time of flight sensors, so I'm not relying on any sort of sensors to determine distance. I'm instead using the reliability of the stepper motors, and I've calculated out kind of based on geometry and I guess also a little bit of trial and error. How many steps equals what distance of movement on the rails that I'm using on the lead screws. So electrically, this is just so much more simple. So we can kind of start with this DC motor here. So again, I have it going right to the motor driver, but instead of having three connected to one board, I just have one connected to one board. So it's just very straightforward. We have these two wires, they go here, and then they just output to this motor. And then this motor is controlling the slider, which opens and closes to grab ingredients. And then now I have three NEMA 17 motors. One of them is used for the horizontal lead screw, and then one for each vertical lead screw. And then there's no need to have any sort of sensors associated with them because they're just very accurate. So electrically, it's quite simple. So the only things I need coming from the board are I need one enable for each, or for the ESP only needs to connect one enable to each A4988 motor driver board, and that just decides which one I want to turn on at which time. So that kind of just, yeah, which one do I want to select to turn on? And then I just need one step and one direction, and I can actually connect all those wires because by allowing me to turn on and off each board as I please, it means that I don't need separate wires connecting for each of these. And yeah, it was very straightforward. Simply just connected these up as shown, and everything worked very well. It was very straightforward. Please mind my fire alarm. But yeah, that's the second one.